Hi, we are going to see in this video the construction of PDA for the language WR. That means W represents string and WR represents the reverse of the string, where the input for this is A comma B, the whole closure. That means even null will be accepted in this particular string, right? Now when this is so, the option now it goes to the type of a non-deterministic push down automata. Now what is meant by non-deterministic push down automata is that non-deterministic push down automata is that for single input there will be more than one next status, and that is called as non-deterministic. That is, machine is not determined to move to which next state. So here, so to design so what is the concept we have to think here is that always the initial state of the machine is q naught and the first input. So here it is not mentioned whether the string starts with A or B. It can be either A or B. Suppose the string starts with A, means now A is the input and we know the stack top is Z0, right? So the transition will be to push inside the stack. So it will be in the same state, since it is closure, so it will be a loop, right? 0 or more. Next one is that the stack operation is A Z0, right? Now suppose if the string starts with B, means now same sequence only, the string starts with B and that means input is B, then stack top is Z0, and then the transition function will be B Z0, right? So that means we have a stack Z0. So when A is the input, A is pushed in. When B is the input, B is pushed in, right? But either one will happen, not both. So when you write for the next feature, so we can have a string like something A B B A A. It's a reverse, right? Now so we can have after A either A or B, and the same condition when you have something like this. So after B it can be a B or a A, right? So in that state what we have to do is that we have to consider both the stack tops. Now who is the top here? Either A or B. So the next step is that it's Q naught, same state, A is the stack top, because for A next we are expecting another A, right? And the chance is we can expect a B also. Stack top is A only, right? Now what we have to do, we are just going to push it off because we are checking for a reverse of a string. We cannot specify that it may be reverse. Suppose if AA is the string, right? Now this is the W and this is WR, right? So in that cases, now what is the point here? It is not determined whether to, if this is the condition it has to push, if this is the condition it has to pop. So that case will be evolving here, right? So that it becomes as Q naught. Suppose if it is a push operation AA, right? Suppose if it's a pop operation, we have an operation change, so state change here, and then it is null, right? Now after that we have something like so Q naught, suppose B means it cannot be popped off here because for reverse it should be same only. So it is just only the push operation that can be performed, right? Got it? Now next thing is we have seen the top for A, stack top is A, that is for this condition. So like that means you have Z0 A on the top. Now it can be either A or it can be either B. Both can happen, right? Now this one is this and this one is this. Now same condition for when you have A over the stack top B, and same condition B over the stack top B, right? Now what will happen? Now again same condition here. Suppose we have a string BB, right? WWR. Now suppose if it's we don't know whether to push or pop here, so machine is confused here, right? If this is the size C, BB, BB, you have two conditions there. Now when this is the condition, this here have push and pop, whereas here push push pop pop, right? So we have again the same situation for this condition here, right? So if it is different means then what we are going to do, it is just a push operation, q a b, q naught a b, right? Now suppose if it is two conditions arise here, so what happens? So it is q naught. Now what happens with the q naught? Either to push, so if it pushes it becomes like this, if it is pop it becomes like this. Now that is a state change. Right? Now this is the two conditions we have seen. Fine. And now comes the next state, that what is the next condition on the acceptance. Suppose over the reverse we have got, right? Now what to be done there? It should perform a pop operation, right? When it is same, that is when for this b it receives another b, then it should be a pop operation. For a, when another a is found, right, then it should be a pop operation. So what is the condition here? So state change, and we are having a and a on the top, right? Or else same only, there is no option that the b top, no, there is no transition function at all, so there is no possibility of that state itself. So here it is b over b, right? Only these two conditions are possible. So if this is the condition, then it remains in the same state, and pop operation is performed, and it remains in the same state and pop operation is performed, right? And since we have the condition closure, right, that means 0 or more. Now what happens here? We have another condition that it may have only null input, not a or b, then again it is accepted and goes to the next state. String, this is a null string acceptance. Right? Now next thing, as usual, after all these conditions, push operation, pop operation, we have a last one is language acceptance. Right? For language acceptance, same states only thing is state names will be changing, right? So null input is null, stack top is q naught, q1 input is null, stack top is q naught. We know that if it is in same state and the stack is empty, this is accepted by empty stack, and when it is you are having qf z0 is there, then this is accepted by final state, right? That's all. So this, the overall specification shows you that this is the design of the PDA for the language WWR, right? And this is an example for Npda. Thank you.